Alright, let's go over the new PowerPoint. So, we learned physical versus chemical. Now let's learn the difference between intensive versus extensive. Has anyone ever heard intrinsic? Does anyone know what the word intrinsic means? It's a very common word, at least in the science community. So let me get a definition. Intrinsic belonging naturally. Are essential. It means it's a natural part of you. And intensive is related to intrinsic. So, physical properties of a substance are characteristics of a substance that can be used to describe it. We've covered physical properties last unit. We're now looking at breaking physical properties up. So all the physical properties are the characteristics of a substance that can be used to describe it. Describe its appearance. There are two types of physical properties. Extensive. Extensive properties are directly related to the size and amount of a sample. So, extensive properties only deal with size or amount. If I tell you I have 1 liter of a mysterious liquid, would you drink it?
Yes.
So,
What color is it?
so me telling you how much its volume, 1 liter, doesn't really tell you too much about the liquid. It does tell you how much there is, but it's not really intrinsic to that liquid. If I have 1 liter of water and I dump half of it out, so I only have half a liter, is it still water?
Yeah.
Yes. So it's it's not very useful quantity extensives are, but it does help you in telling you how much you have. Intensive properties, however, are properties that are not related to the size or amount of a sample. Intensive properties are ones that, so if it's not related to the size or amount, it means that they are intrinsic, are naturally a part of that substance. There are 3 primary extensive properties that are related to the size of a sample. The first one is mass. Mass is related to the amount of matter in a substance. The larger a sample is, the more mass it has. So, for extensive properties, if you add something to it, does the value change? So if I start with 1 liter of water and I add another liter to it, did the volume change?
Yes.
So that means it's extensive. If it changes whenever you add more or remove it, it's extensive. So extensive is going to directly depend on size or amount. Volume is the amount of space a sample occupies. A smaller sample would take up less space, so volume is extensive. So if you can remove it and the value changes, it's extensive. Should be very easy to remember and tell the difference between the two. Length. Length is simply how long a sample is. Width and height are also just lengths. So if I have a 10-foot rope and I cut it in half, did the length change?
Yes.
So that means that length is extensive. If you remove some of the rope and the length changes, that tells you length is an extensive property. There are also 3 secondary extensive properties that are directly related to the mass of a sample. The number of moles of a sample is also a measurement of the amount of matter. We will learn later how to convert between grams and moles. But for right now, has any of y'all ever heard of the unit moles?
Negative.
So a mole is a counting number. Does anyone know what a counting number is?
It's like a natural number. 1, 2, 3, 4.
A dozen, or I should say, is a counting unit. Counting unit. So a dozen. So if you have 1 dozen eggs, you have 12 eggs. A dozen is a counting unit. It's not a real unit. It just counts how many objects you have. So you have a dozen of eggs. You don't really say that in proper English, but you do with mole. If you have 1 dozen eggs, you have 12 eggs. If you have 1 mole of eggs, you have, let's see if I can find. You have 6.022 times 10 to the 23 eggs.
That's a lot of eggs.
That is a humongous amount of eggs.
Probably not many eggs that touch the earth.
Y'all stop that. Let's see if I can find you guys some fun facts about how big that number is. If you had a mole of rice grains, you know how big a grain of rice is?
That's big, big as my brain.
It would cover all the land in the whole world with rice about 75 meters tall.
Sick. Did you die? That's some sick rice.
1 mole of rice is more grains of rice than has ever been grown since the beginning of time.
Called it.
1 mole of rice would occupy a cube 120 miles on one edge. A mole of marshmallows would cover the United States up to 600 miles tall.
Wow. Just boom. So you're telling me kids, that's weird. If I get a mole of guacamole, hashtag sheep that. Which had discussed hashtag mole.
If you could create a mole of pennies and give it to all 6 to 8 billion people in the world, and y'all were to spend, if we were to take 1 mole of pennies and give it equally to every person on Earth, and they were to spend $1 million a day, it would take 3,000 years for everyone to run out of money.
Jesus Christ.
I was hoping I could find the distances.
It sounds to me like it could last the Earth.
Not even that much copper.
All right. So why do you think we have such a humongous number?
Because it can.
For safe measure.
So, do y'all know how much a gram is?
Yes. I have a scale that does that too. Y'all don't have a gram? Oh, we have one. I measure my grams for drugs. Oh.
So here is a gram of carbon. It's 1 mole of carbon atoms. There is an insane amount of atoms and fit into a very small amount. Moles are useful for counting atoms. There is an insane amount of, there's probably, in this Coke bottle right here, I would estimate there's between 2 and 7 moles of water, H2O.
What about the entire Earth? Would there be like a mole of atoms?
So if this was a couple of moles of water, think about the ocean. So moles is useful for counting atoms, and we had to get a crazy big number to count atoms. Energy. Energy is directly related to size. The amount of potential and kinetic energy of an object is directly related to the size and mass of that object. If you can remember back to our energy equations, we had kinetic energy is 1/2 times mass times volume squared. It depends on mass, and potential energy is dependent on mass too. And, yes? The number of particles, which is very similar to moles, is also directly related to grams and moles of a sample. Again, extensive properties, if you add to it, does the number change? If I tell you have 10 particles, and you add 1, it becomes 11. That number changed. Anyone know what, and keep your mask on? Do y'all know what a mnemonic is?
What? I've heard the word.
It's where you have, it's a memorization technique.
A mnemonic plate?
If you remember this abbreviation, MVL min, mass, volume, length, moles, energy, and number of particles.
Those made out of paper.
No. Yeah, no, we put silicone in them.
Oh, okay.
So, these are the only extensive properties.
How big do
You guys, cool it and keep your mask on.
Totally different conversation. Why did you say that to me?
Alright.
Because he's trying to
There are many intensive properties that are not related to the size of a sample. Because this list is much larger, you should focus on remembering that shorter list. Remember mass, volume, length, moles, energy, and number of particles. If it's not on that list, it's going to be intensive. So let's look at one color. If you have a gold bar and you break the gold in half, does the color change?
Just look at breaking it. No, put your hand. It's pretty soft.
So if something is solid and you remove some of that solid, does it change? Is it still solid? So that's intensive. The fact that it has a certain color, whether it's solid, liquid, or gas, doesn't depend on the amount. And y'all quit. Density. Y'all quit moving y'all's head. So, the density of water is 1 gram per cubic centimeter. It doesn't matter if you have a drop of water or a liter of water. It's always 1 gram per cubic centimeter. To show you this, here we have a rod of a mass 17.5 grams and a volume of 13 cubic centimeters. Density is mass divided by volume. If you remove some of the mass, the volume also decreases. So if you reduce the mass down to 8.75 grams, the volume would decrease to 6.5 cubic centimeters, but the density stays the same. If you add mass, the volume is going to increase, but the density stays the same. Because of the relationship between mass and volume is independent of both, that makes it intensive because it doesn't change when you add to it. Temperature. Temperature is also intensive property. This is because the temperature of a sample depends on its surroundings, not its size. If you have an object that's at 70 degrees Fahrenheit and you remove some of it, you don't change its temperature. Some elements like copper and aluminum can appear in a number of different shapes. A substance that can be drawn out, especially in the wires, is called what? Ductile.
Yes.
So a substance that can be drawn out into wires is called ductiles. If a substance can be bent or flattened, especially into thin sheets, is called
Malleability.
malleability.
That's right, Christian.
Some elements are attracted to magnets. They can be made into magnets themselves. So the fact whether you have a small paper clip or a large paper clip, they'll both be attracted to a magnet. So it doesn't matter on the size of the paper clip, they're still magnetic. There are 3 major elements, iron, cobalt, and nickel, that are ferromagnetic. Not only are they attracted to magnets, but they can be turned into permanent magnets themselves. They're known as the iron triad. And they're all next to each other on the periodic table. So let's sort some of these. So color, is it intensive or extensive?
Intensive.
Does it change if you remove or add?
Intensive.
Odor, so is that intensive or extensive?
Intensive.
Intensive. A rotten egg smells bad. Doesn't matter if you remove some of it. It's still going. The odor doesn't change. Melting point.
Intensive.
You can describe the melting point of water without having to describe its size. Mass. Extensive. Boiling point. Volume. Density. Density doesn't depend on size. When we want to ask what's the density of lead, note that I didn't ask for the density of 5 grams of lead. Doesn't depend on size, so it's intensive. Length.
Extensive.
Specific heat. Intensive. Specific heat relates to, we covered this before in physics, relates to how much energy is required to heat something up. It's 4.184 joules per kilogram degree Celsius. It's the same for all water. Temperature. Energy. What?
Extensive. Now.
Extensive. MVL. MEN. MVL men. That's the E in the men. State of matter.
Intensive.
Intensive. Alright, I want to go over a few examples of density. So what is the equation for density? Density is equal to mass over volume. So density is equal to mass over volume. So mass over volume is equal to density. So if the density of water is equal to 1 gram per cubic centimeter, how many grams of water is in 591 cubic centimeters? So we're solving for mass. Mass is thus equal to density times volume. The density is 591. Density is 1 gram per cubic centimeter. The volume is 591 cubic centimeters. So the density, the mass